So first of all, framing, basically the figure of the problem, figure given in this problem. So we don't need to draw. Maybe we can apply free body diagram for now. So what was the free body diagram? Basically forces, all forces acting on each object. So each one has its weight, vertical downward, and the reaction force perpendicular to the surfaces, and the tension, T2 and the T1. Now let's come to the planning. So it's obvious that this is the dynamics or Newton's law. We can apply second law, which means F equal to ma. Like we will apply Newton's second law, resultant force equal to ma for each object. What else? What we can say about their accelerations? We have two objects, so it means we have two accelerations, a1 and the a2. What we know about these two accelerations? We can conclude, we can say that these two accelerations equal to each other. Why? Because the length of the rope is constant. This is not so when the meaning of this one is when the first object, for example, shifts for 1 meter, second object exactly will move for the same distance for 1 meter. It means they have the same velocity always. It's changing, but they will have same velocity at any time and the same acceleration. It means also tension. They are also equal to each other because the rope, the string here is massless. When the rope string is massless, in this case, tension or force in the rope everywhere at any point will be same to each other. What else we can say about this problem? Free body diagram, we already did it here in previous part. That's all basically. Since this is forces, we can use vector methods, components, etc. Now let's come to the solution. So first of all, we should guess the direction of the motion. We have the same angle here, so it means here we have at right side we have 8 kg, at the left side we have 3.5. It's obvious that 8 kg will move downward because angle is exactly the same and 8 kg is heavier than 3.5. Okay, now let's apply Newton's second law, resultant force equal to ma for both objects. Let's start with the first object. It will move in this direction due to the component of its weight. So its component in this direction equal to m1g sine alpha. Alpha let it be 35. So resultant force in this direction equal to m1g sine theta minus tension m1a. So this is Newton's second law for the first object. For the second object, it will move in this direction upward basically because tension is greater than the component of the weight m2g sine alpha. For the second object, tension minus m2g sine alpha because this tension should be greater than this force, so it could move upward, equal to m2a. So they have the same tension, we already explained it here. They have the same acceleration, we also explained it in previous part, in planning part. So as you see here, we have two equations and the two unknowns, and it's simple to solve. Let's add these two equations. So m1g sine alpha minus m2g sine alpha equal to m1a plus m2a. From here, acceleration equal to g sine alpha m1 minus m2 over m1 plus m2. So let it be 10 gravity sine 35 times 8 kilogram minus 3.5 over 8 kilogram plus 3.5. So approximately acceleration will be equal to, now let's use our calculator, 8 minus 3.5, 4.5 times 10 times sine 35, 25.8 divided by 8 plus 3.5, it's 11.5. So approximately we have 2.24 acceleration meter per second square. So how we can check this acceleration? This acceleration is less than gravity, so 2.25 is less than 10 free fall. It's physically, it's logical, because these objects, it's not falling, they are not falling in the air. We have a system, we have a rope, so it cannot fall with acceleration greater than 10. We have less than gravity, 2.25, and the sign is positive, so the directions that we discussed before is correct, and the value is likely correct because it's less than 10. It cannot be greater than 10 because there is no external forces or motor inside this object. Now let's come to the tension. We can come back to one of these previous equations and find tension. So let me use first equation, this one. From the first equation, tension equal to m1g sine alpha minus m1a. So m1g sine alpha minus acceleration, 8 kilogram, 10 times sine 35 minus 2.24. So tension will be equal to 10 times sine 35 minus 2.24 times 8. Acceleration equal to approximately 28 newtons. 28 newtons. So let me check m1g sine alpha. This will be equal to 8 times 10 times sine 35, and this will be equal to approximately 80 times sine 45.8 approximately. Why we are calculating this? Just to check. We know that this object moves downward. It means m1g sine theta should be greater than tension. In our case, tension equal to 28 and m1g sine alpha equal to 46 approximately. So we think our solution is correct because tension cannot be greater than 46. In that case, this object will go upward, not downward.